us to another episode on ASUG 12 exams. So in this episode, we are looking at the 2018 Science Paper 2, which is basically chemistry. So let us straight move to section A, which carries 20 marks out of 85, and there are 20 multiple choice questions. Question 1. Which one of the following sublimes when strongly heated? So basically we are looking for one of these compounds that are basically sublime. So what is to sublime? So sublime is coming from the word sublimation, which is basically the direct change of state of a substance from solid to gas on heating, or from gas to solid on cooling. So it skips the liquid state, so it moves direct from gas to solid, solid to gas. That's sublimation. So basically there are four substances that are basically sublime, and these are iodine crystals. Number 2, ammonium chloride, which is a salt. Then we have ammonium sulfate, which is also a salt. Then carbon dioxide, which is also known as dry ice. So out of those four, you notice that here in this case only the iodine crystals is appearing. So D is the correct answer. We move to question 2. Identify the measuring apparatus shown in the diagram below. So if you look at this apparatus, what you discover is basically this is known as a volumetric flask. So what is the use of this, which you need to know, because a question might come, you're given this, then they ask you what is the use. So the use is basically it is to measure the fixed amount of liquid. Okay, that's what it is used. So other apparatus that you might also need to know, just in case, because questions are varied, is also basically number 2, it will be a bullet. So a bullet is a special apparatus which is used to measure volume of liquid with the degree of accuracy of 0.1 centimeter cubic. So if you come across a question that is asking you about the apparatus that you can use, to measure the volume in decimal points, then a bullet will be ideal. Then also you also need to know a pipette, which is basically just used to transfer measured volume of liquid. So it's just transferring a given amount of volume which has already been measured. Then also you also need to know about the measuring cylinder, which is also used to measure the volume of liquid with degree of accuracy. This one is 1 centimeter. The degree of accuracy is 1 centimeter. So anything in whole numbers, this would also be used, would be one of the best apparatus. Then lastly is you see which is the conical flask. So the conical flask is used for holding and mixing liquid. So what you do is you can swirling the liquid as you are using it. So basically this one just measures liquid according to graduated marks. So there are those marks that are already graduated. That's what it is used for. So basically this is how you answer question 2 and the key things that you need to know related to apparatus. Let us look at question 3. What term is given to atoms of the same element with the same atomic number but different mass number? So basically what is key here is basically this is the same element with the same atomic number, then different mass number. So if your atomic number for these atoms is the same but mass number is different, what it means is the difference is coming from neutron numbers, because remember, proton numbers plus neutron numbers, you get mass number. So mass number is basically the total number of protons and neutrons in a given atom. So let's look at basically the options. So we have isoelectronic. So isoelectronic, so basically this one refers to two atoms, ions or molecules that have the same electronic structure and the same valence. That's what A means. So A is not correct. If you look at B isomers, so isomers are basically these are organic compounds with the same molecular formula but different structures. So B is not correct. You look at C, C is basically the correct answer, which is basically the same element but having different mass number, the same proton number but different mass number. So C is the correct answer in this case. Just to look at D isobars, in case you don't know what isobars are. So isobars are basically these are atoms of different elements having different atomic numbers but the same mass number. Example, we have calcium, which has basically mass number of 40 but atomic number 20. Then we compare it to argon, which has basically mass number of 40 but atomic number of 18. So those are what are known as isobars. Let us look at question 4. Metallic bonding is there. So want to know what metallic bonding is. So loss and gain of electrons between metallic and non-metallic atoms. This is known as basically ionic bonding. So it's not a metallic bonding. We go to B, a sharing of electrons between non-metallic atoms. This is known as convalence bonding. So this is convalence, and this is ionic. C, the force of attraction between valence electrons and the metal ion. This is basically the correct answer. So basically metals are basically they lose electrons, those free electrons that are able to be released, so that they create the bond with the other metals. So C is the best answer. So without even looking at D, we can proceed, because D is saying electrostatic force that exists between all protons and the electrons. This is not true. We look at question 5. Which one of the following oxides can be neutralized by both aqueous sodium hydroxide and sulfuric acid? So we are looking for basically an oxide which can be neutralized by aqueous sodium hydroxide and acid. So this is basically what is known as amphoteric oxides. So these are metal oxides that can react both with acid and bases. So what you notice, this is a base, then this is an acid. So there are certain oxides that react with both acid and bases, and these are known as amphoteric oxides. Amphoteric oxides. So examples of amphoteric oxides include aluminium oxide, which is this one. Then you have zinc oxide. Then you have the third one, which is lead oxide. These three are known as amphoteric oxides. So if you check among the option, what you discover is we only have basically a D, which is basically lead to oxide. So this is basically the answer. Let us look at question 6. Start the reaction scheme below. So we have black solid A reacted with dilute sulfuric acid. We end up with a light blue solution B plus a liquid C. When a B is reacted with sodium hydroxide followed by excess of it, we get a light blue precipitate which persists, and this is insoluble in excess. So identify the black solid A and liquid C. So if you look at basically the color, this is light blue solution. So light blue solution, this one is basically the identity of copper sulfate. So this is copper sulfate. So if this is copper sulfate, basically this is a salt. So if B is a salt, what it means is this should be an oxide, and this, if this is copper sulfate, this should be an oxide of copper, which should be basically a copper oxide. So this should be a copper oxide. So if this is copper oxide, what we need to know is basically, you know that copper oxide is a base. So base reacted with acid, we end up with neutralization, which is basically a salt plus water. So basically this liquid C should be basically water. Then we can proceed, because we're only requested to identify A and B in this case. So what you notice here is basically A is copper 2 oxide, so it's not B, it's not C. So remain with A and D. Then we know that C is water, so basically you notice that A is the best option. Perhaps maybe someone would be interested to know what D is in case the question came. So you know that this is light blue precipitate. So what this tells us, this is the effect of basically a sodium hydroxide on copper ion. So this is when testing for ion, you discover that copper ions will give this light blue precipitate once reacted with excess of sodium hydroxide. So basically this is what is happening. So this one are basically copper ions. Let us look at question 7. 7.8 grams of pure zinc metal was reacted with 100 centimeter cubic of 2.0 moles per decimeter hydrochloric acid. Which one of the two substances was a limiting agent, reactant in excess, and collect formula for the products? So basically what we are seeing here is we are reacting zinc metal, which is solid. We react it with basically hydrochloric acid, which is aqueous. So now what will happen is because zinc metal is more reactive than hydrogen on the reactivity series, is going to replace hydrogen on the hydrochloric acid. So we are going to have basically zinc chloride, then plus basically hydrogen gas. This is what we are going to have as the two products. So what we need to do is basically before we do anything, we need to balance this equation. So we know that we have two hydrogen here, but this side we have one. So here we need to put a 2 such that this could help us to balance. So you know that there are now 2 chlorine, and this side there are 2 chlorine, so it balances. Then we have 1 zinc, 1 zinc. So the equation actually does balance. So let us look at the options before even know we can eliminate which ones are not the products. So we know that the products are basically these two. So we know that there is no water because there is no oxygen there. So basically it's not an oxide unless it was zinc oxide. So B is not correct. Then and also D is not correct. So if you see basically number C is incorrect in the sense that the formula of zinc chloride is remember zinc as basically positive 2. So these need to be 2, not 1. So because you notice that this is incorrect, though this one is correct, this one is incorrect. So C is not correct. Hence, you notice that we only remain with A. So A in this case would be the correct answer by default. So if you are to be asked to calculate basically the limiting agent, what you need to do is basically after we balance this equation, we notice that we have the moles 1 to 2. So what it means is if we have basically 2 moles of hydrochloric acid, we need 1 mole of zinc metal. So what we need to do is find the number of moles that are here in this hydrochloric acid, which is just given by basically the number of moles will be equal to from molarity formula. So molarity formula is basically equal to a number of moles divided by volume. So to find a number of moles, we just multiply by molarity m multiplied by volume. So molarity is 2. Then we convert this to decimeters, which by dividing by 1000 we end up with 0.1. Then we multiply that, we get 0.2. So what it means is basically here we have 0.2 of hydrochloric acid. Then basically what are we supposed to have of zinc? So what we do is basically we divide 7.8 to find the number of moles. So the number of moles of zinc will be basically mass given, which is 7.8, divided by the mass number of zinc, which is basically if you check on the periodic table is 65. When you divide that, we end up with basically 0.12. So this is 0.12. So we are supposed to have 0.1, but we have actually 0.012. So ideally, in actual sense, basically zinc should be in excess. Zinc should be in excess because we have more moles than required. So we have 0.12 instead of having 0.1. So basically zinc should be should be in excess. Then hydrochloric acid as a limiting agent. I think this one was a technical error, because zinc would be a limiting agent only if this formula was the case, but this formula is not true because zinc has +2 ions. That's why the formula of zinc chloride is given by this. We move to question 8. How many moles of oxygen gas would occupy a volume of 1200 centimeter cubic at room temperature and pressure? So what we know are basically the number of moles occupied by a gas at room temperature is given by a volume given in this volume in decimeter cubic, then divided by basically 24 decimeter, which is the volume occupied by a gas at room temperature. So we're given this, we divide it by 1000 to convert it to decimeter. So n equals to 1000 divided by this one, it becomes basically 1.2 divided by 24. If you divide this, you're going to end up with basically 0.05 moles. So basically what you notice, A is the best answer in this case. So basically this is how you handle that. So you look at the periodic table, you find this number is there at the bottom of the periodic table, just in case you forget. Let us look at question 9. A learner carried out 4 experiments on rates of chemical reactions. The results of the experiments were recorded on a graph as shown below. So what we have basically, we have basically a time in seconds, then we have volume on the vertical axis. Then the question, which reaction shows the fastest reaction rate? So basically we want to see which one finished first. So what we need to understand about this graph, the graph of rate of reaction, basically zero gradient tells us basically that a reaction completed. So like here what is telling us, no matter what time, no matter the time we take, the volume here will not change, will remain the same. That's what it implies. Then basically a steep gradient at the start means that the reaction is fast. So when the gradient of this curve is steepest, is where the rate of reaction is high. Then when the gradient basically decreases, it means reaction slows. So we are looking for which one finished first. So what you notice here is one finished here at this time, then 2 finished here, which is either than 1, then 3 here, which is either than 1 and 2 and 1. Then you notice that 4 are finished somewhere here when it became flat. Somewhere here it became flat. So basically 4 finished area. So it was the fastest reaction. And in terms of slope, you will even notice that it has the highest slope here reached by compared to the other. So basically 4 is basically the fastest reaction rate. So D is the best answer. Let us look at question 10. Element W has high boiling and melting points. It forms 2 oxides, WO and W2 oxygen 3. This element is, so basically ideally we want to identify what this element is. So basically we have an alkaline earth metal, a chalcogen, a transition, then a halogen. So basically the first clue to the question is that this is basically as high boiling and melting points, meaning this is basically a metal. Number 2, this is forms 2 oxides. So the element that forms 2 oxides are elements on this side of the periodic table, this side. So these are basically known as transition metals. So basically C is the correct answer. Just in case you are wondering, basically an alkaline earth metal, these are group 2 elements, and these are the elements that you see here, starting with your barium, magnesium, calcium, going down. Then you have basically this one, the chalcogen. So these are group 16 elements, and they consist of 4 elements, which is oxygen, sulfur, selenium, and tellurium. So these elements that are found here, these elements under group 6. So these 4 elements are the ones that are known as chalcogen elements. Then halogen, of course, you know these are basically group 7 elements. So basically this is how you answer question 10. Question 11, rubidium is in group 1 of the periodic table. Which element is in the same period with rubidium but found in group 5? So we need to go and look along the same period with rubidium but in group 5. So the period dual rubidium is this one. So we move along this line until we reach group 5, which is this one. So this is where group 5, so it's this element which is SB, which is antimony. So basically we need to go and look for SB. So this is the answer, which is antimony. So basically know how to read the groups of the period and the periodic table and the periods. Then such kind of questions will be much more easier for you to deal, because answers are already given. That's why it's difficult for you to fail if you only understand the question. Let us look at question 12. Metals are able to conduct electricity because. So why are metals able to conduct electricity? So metals are able to conduct electricity because they have delocalized electrons. Basically this is the answer. So if you read about the property of metals, you discover that basically this is the property which is key for them to conduct electricity. Let us look at question 13. A learner set up the following experiments using iron nails. In which test tubes will the nails rust? So we need to know what conditions are needed for rust to occur. So rust is basically hydrated iron oxide. So this is the iron 2 oxide. So basically what is happening is, for rust to be formed is basically we react basically iron, this iron solid is reacted with basically oxygen, which is a gas, plus basically water. So two things are needed for a rust to happen. So we need the presence of water and oxygen. Okay, then it will occur. Then this will give us basically this. Okay, so this is basically the rust we are talking about. So if you look at the first experiment X, in this case we have water, then we also have the presence of air. So these two conditions are met. So in this case basically this would happen. Then when you look at why we have oil, since we have oil on top, what it means is we have water, but we don't have the presence of air there. So in this case there will be no rust. Then if you look at Z, so Z basically we have this one closed, meaning we only have air trapped inside. But because there is a cotton wool here, which is going to nuke any moisture that can be created here, then and also there is a calcium oxide, which is more reactive than iron. So in this case the rust may not occur. So what you discover here is the best answer here would just be basically X, so which is C. So C is the best answer. Let us look at question 14. Which gases make up more than 90% of dry air? So basically the question is asking us basically the gases which makes up more than 90% of the dry air. So what we need to know is the composition of air. So what you need to know is basically a nitrogen is very clear. This is basically 78%, which is the biggest composition of the dry air. Then of course number 2 you have oxygen, which makes up 21%. Then you have argon, which makes up 0.9%. Then you have carbon dioxide, which makes up basically 0.03%. Then of course we have others, which is making up 0.09%. So what you need just to do is to add. So if you say nitrogen, which is 78, plus argon, which is 0.9, plus carbon dioxide, which is 0.03, this is cannot be 90%. B, nitrogen 78% plus 0.03%, it cannot add up to 90%. C, oxygen, which is 21% plus carbon dioxide, which is 0.03%, this is basically less than even 22%. So notice that oxygen, which is 21%, then add 78%, this gives us 99%. So basically D is the correct answer. We go to question 15. In a particular laboratory, the following elements were in stock: zinc, copper, sodium, carbon, and iron. The arrangement of the elements in order of their decreasing reactivity is, so basically you notice here is basically they're asking us to list them in decreasing reactivity. So meaning you start with the most reactive, then end up with the least reactive. So the best way to remember this, there are so many ways that you can remember the activity series, but one of the most famous is the one as please stop calling me a careless zebra. Instead, try learning how copper saves gold. So you see this, and of course we have also platinum at the end. So what you notice here is, in this case, this is basically potassium, then this is sodium, then of course we have calcium, then we have of course magnesium, then we have aluminium, then this is carbon, which is one of the special non-metal. Then basically we have this one is zinc, then we have of course iron, then we have tin, then we have lead, of course we have here hydrogen, which is also a non-metal, then we have copper, then we have silver, this is silver, then gold, then platinum. So once you know this, it's much more easier. So now let us start with the most reactive amongst this. We know that sodium is the most, sodium should be 1. So if you check from the option, the one we start with copper out, so B is out. So the next on the list from sodium, from what we have, basically you notice that the next will be basically carbon, which is here. So carbon should be number 2. Carbon should be number 2. So you come on the options, you discover that this is zinc. Zinc is lower than carbon, which is here, so it cannot be, so A is out. Then remain with C and D. Then you also notice that this iron is lower than carbon, so it cannot be correct. So you notice that we have sodium, carbon, zinc. Zinc is higher than basically iron, which is true. Then zinc is higher than copper, which is here, which is true. So you discover that C is correct. So this is how easy you can answer this question. Let us look at question 16. The diagram below shows the setup used to detect the presence of carbon dioxide in polluted air. So we have polluted air, enter there, then passes through the solution X and is filtered out to the pump. So solution X is, so what we know is we want to detect the presence of basically carbon dioxide. So carbon dioxide basically turns lime water milk as a way of knowing it. So basically what do we use to test for the presence of carbon dioxide? So this one is the lime water, which it turns to milk. So what is lime water? So lime water is basically aqueous calcium hydroxide. So let us look for calcium hydroxide in aqueous state. So this is basically the answer, which is A. So this one is straightforward. So basically you need to know the test for gases, and also a test for cations. So you need to review them and ensure that you prepare for such kind of a question. Let us look at question 17. The diagram below shows the fractional distillation of crude oil. Which explanation below is a correct reason for the fraction H to be collected below fraction G? So basically we are seeing that H is here, then we have G here. So the question is, what's the correct explanation for H to be collected below the fraction of G? So basically we have the options. So we have A, G, H is greater than G. So what we notice here is, what is key is basically the temperature in this fractioning column basically increases as you go downward. So the temperature increases. Then in terms of also the size of molecules, the molecules also they increases as you go down. That's why they need more temperature. They need a higher temperature, so they have got a higher melting point. Then the smaller ones are on top. Smaller ones with smaller molecules are like petrol. Then you have a naphtha. Then basically you have something like here kerosene. Then you have of course diesel, which is slightly heavier. Then diesel. Then you have basically the fuel oil. Then of course here at the end you have the bitumen. So residues. So these are things that you need to know. Once you know these things, you see much more easier. Then here we have a gas. So what will happen is basically in terms of the average size of molecules, the molecules at H are greater than those at G. That is the case. So B and D are out. Then in terms of boiling point, so the boiling point at H is higher than at G. So boiling point at H is greater than or higher than at G. So what you discover is C is out, A is the best answer. Let us look at question 18. The substance that conforms to homologous series with a general formula, this general formula is, so we know that these are basically alkenes. So if the alkenes, it should end in this ending. So we notice that this is a carboxylic acid, this is the alkene, this is alkane, and this is alcohol. So we know basically B is the correct answer. Then 19, which of these organic compounds will decolorize bromine vapor? So we know that this is unsaturated organic compounds. So these are basically hydrocarbons compounds. So these they undergo addition as opposed to the alkynes, which do not, because of their strong single bonds. So in this case we need to look for the alkene from the options, or alkyne. So what you notice here is this one basically is basically alcohol. So it's not correct. This one is basically the one that conforms to this general formula. So basically you notice that B is the correct answer. Let us look at question 20. Study the organic structures below. So we have 4 organic structures. Which of the above structures are isomers? So the key is we need to identify which ones are isomers. So what are isomers? Isomers are different compounds which have the same molecular formula but different structural formula. So what you need to write there molecular formula. So the first thing that we notice here is this one is an alcohol, and this is the only alcohol which is here. So this one is out. So anything with one is out. It's the only alcohol which is there. So and C is out. It can't have an isomer because just alone there. So remain with B and D. So number 2, we know that these are 4 carbons. Then we have 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen. Then I will come to number 3. So we have also 4 carbons. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen. So we notice that this one and this one, they are the same. We go to number 4. We have 1, 2, 3, 4, 5. So now here there are 5 carbons. Then how many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So what you notice that this one and this one are out. So it's basically number 2 and number 3, which is basically B. So B is the correct answer. So this is, we have come to the end of this episode. We are looking at the multiple choice questions. Please check out for episode 2, which focuses on section B, and episode 3, which focuses on section C of this paper. Thank you for joining me on this episode.